So if humans are one day able to live on another planet such as Mars, we're going to need to learn to make things to survive while using limited resources. Professor Ramil Shah from Northwestern University is now 3D printing with lunar and Martian dust. And you might be asking why. Well, I was asking the same question. So she is here this morning to explain all about this. Thanks for coming in.
Thank you very much.
Okay, what's the purpose of doing 3D printing with these lunar dust? Why?
Well, if one day we are needing to, colonize the planet and make it a habitat, we need to be able to use resources that are there.
Okay.
So one of the things is trying to take dirt or, what's found on the surface and making them into functional objects.
Okay, how in the world do you do that?
So one of the major efforts in my lab is to really expand the number of materials that can be printed, 3D printed, into functional objects, going beyond just prototypes or plastics, right?
Okay.
So what we've done is we created these different inks. We call them 3D paints because of their similar composition to household paint.
Okay.
Where they have particles in there, if you can see here.
Okay, so that's just
yeah, this is from Martian dust simulants.
Oh, it is?
Exactly.
Oh, look at that.
It's actually NASA approved. It's very similar to what's found on Mars.
Okay.
And what we can do is we turn them into an ink. So a 3D printable ink. So it has a consistency like if you see it flow.
Yes.
You can put it in a cartridge. Like here, like this, and you can just squeezes out and extrudes, and it can print into these very three-dimensional shapes.
Okay. So here we go. This is one example. There's a few here. This looks like a Lego, by the way.
Yes, exactly.
Okay, so you've made this from the dust.
Yes.
The 3D printing. And what is the purpose of these things? What would I do with them?
Right. So one idea, and this is a good idea a good I guess image, is that you can build building blocks. So you can have a variety of bricks. You can stack them together. You can actually take more ink and seamlessly fuse them together. So for shelters, for buildings, you can also you can create flexible objects too. So or rubber-like objects. So these, when they're printed, they're actually they look like rubber. So tires, tubing, everyday materials. Also, you can put this in a furnace, and it sinters or combines the particles together, creating ceramic-like materials.
Okay, that's amazing. Right. And did you make your own tools? What is this here?
It's like a wrench. So hopefully, one day you can process the dirt so that it can create. You can isolate it from metal structures, and then you can make tools on the planet too.
Okay, that is amazing.
Yeah.
I feel like I'm playing that game Operation from when I was a kid. All these little parts. Okay, so tell me, what is the purpose in doing this? Like, what's your long-term goal?
Well, our long-term goal is to really take 3D printing and being able to use it as a tool to make a variety of different objects, anywhere from making objects from dirt or what's surrounding to electrically conducting scaffolds to materials used for tissue engineering applications as well. So we can actually print biological tissue.
Did you see that movie Martian?
Yes,
that's what I'm thinking about right now. I'm thinking what he could have done had he had that 3D printer.
Right? No, totally. Yeah, you put the ink, extrude it, and just get what you need.
I love this.
Exactly.
Okay. And then let's talk about this, because before we came on, she was telling me about bone regeneration. So tell us about this example here.
So this is a little Skeletor here. So this is one of our inks that actually has hydroxyapatite, which is the main mineral component of natural bone. Okay. And we've tested this, and we're using it as a bone graft so that once it's implanted in the body, it can regenerate bone, and it degrades over time, and it's replaced by natural bone.
Okay, so it can regenerate bone where? In the skull somewhere?
Head to toe, from cranial to facial to long bone, anywhere you need bone replacement. This allows it to regenerate and induce regeneration in your body, and great for pediatric patients. So it's a not metal, so you don't have to replace it all the time.
Which we hear so much with hip replacements and things like that.
It grows with the patient, and it ends up being natural tissue.
Okay, that sounds very futuristic. Well, how far are we with this, and when will we be actually doing this?
Well, I'm hoping we'll be able to see something in humans in the next 5 to 10 years. It really is dependent on funding as well as regulations, getting over regulations. But hopefully, with these other types of materials, we can get the word out there about the technology itself and its potential. To really use 3D printing as a major manufacturing platform to change the way we make things.
Wow, I love that. Wow, this was so interesting. Thank you so much for coming in and talking to us this morning. I find this all very fascinating. Such a pleasure to meet you.
Appreciate it.
And good luck with all of your work.